Hello. This is going to be part 3 of the video for section 6.4. What we just talked about was the perpendicular bisector theorem. I have a version here that's blank, but obviously you just filled it in. And we have a quick corollary. So corollary word maybe has come up before, I'm not quite sure. But a corollary is sort of a miniature theorem that immediately follows from a more important theorem. So here's what it says. Given a segment AB and a line L in the same plane, if 2 points of L are each equidistant from A and B. So let's kind of draw a picture. Right, so let's suppose here's A and here is B. And I have a line L like so. L here is the name of the line. And maybe I have a point here, X. So I'm saying that X is equidistant from A and B. The distance from A to X and the distance from B to X are the same. And let's suppose that's also true about a point Y also on this black line L. The distance from A to Y and the distance from B to Y are the same. Let me draw those in. So AX is the same as BX. And AY is the same as BY. Well, what did we just learn from the perpendicular bisector theorem? The perpendicular bisector theorem says when a point is equidistant from 2 points, it lies on the perpendicular bisector. So what we know here is that X is on the perpendicular bisector of segment AB. Let me draw in segment AB. Here's segment AB, here's X. X is equidistant from A and B, so X is on the perpendicular bisector. By the same logic, Y is on the perpendicular bisector of segment AB. So the perpendicular bisector is a line. X is on that line, Y is on that line. Well, I have 2 different points from some line. What line are they on? L. So what this means is, therefore, what we can conclude here is that the line XY, aka the line L, is the perpendicular bisector of segment AB. And I want to stress here that we need 2 points to do this. Let me add a page just to really show you what I mean, because there's a subtlety here that often confuses people. If I just draw this picture, here's A, here's B, here's X, and I tell you that AX equals BX. And let's draw in line L. What we know is that X lies on the perpendicular bisector of segment AB. That's what we know from the perpendicular bisector theorem. What we don't know is that this particular line is the perpendicular bisector. I could draw a slightly different line that looks like so and also goes through X. I could draw another slightly different line like so that goes through X. I could draw another one, slightly different line that goes through X. What we know for sure is that one of the lines with X on it is the perpendicular bisector. X is on the perpendicular bisector of this segment. But that doesn't mean any old line we draw is the perpendicular bisector. You can't just assume it's the perpendicular bisector because it kind of sort of looks like it. So be very careful about this. We don't know which line it is. But in the corollary we just saw, the key difference is that I have 2 points. X is on the perpendicular bisector and Y is on the perpendicular bisector. There's only one line that goes through both of them. So when you have 2 equidistant points, you can make that kind of conclusion. Now, we've got another theorem here, theorem 6.3. And this one, if you draw a picture, should feel very obvious, but we want to prove it. So through a given external point, there is at least one line perpendicular to a given line. So here's our setup. I've got this line L1. I've got this point P. And what this theorem is saying is that there is some line, there is a line that goes through P and is perpendicular to this line. Right? If I try to draw it, right here, I'm drawing a line that goes through P. And if I position it the right way, I can certainly make it look like it's perpendicular. Right? It feels like there's got to be one of these various lines that go through P. There's got to be one of them that's perpendicular. Right? That seems reasonable. So here's how we're going to prove it. I'm just going to pick a point on this line and call it X. And I'm going to measure this distance. And I'm going to measure this angle. What we know from the angle construction postulate is that I can create another ray like so that this angle is congruent. However big this angle is, I can build it over here and go in that direction. I can also measure this distance, and using the distance postulate or the ruler placement postulate, measure out the same distance over here. And maybe that gets me to Q. So I'm allowed to find Q that goes in this direction with an equal angle measure and has an equal distance. Now let's just draw any old point Y over here from this line. And I'm going to create two triangles. Certainly segment XY is congruent to itself. So what we'll note here, and I'm not doing a full two-column proof, I'm just trying to walk you through this. We can observe that by side angle side congruence, triangle XPY is congruent to triangle XQY. Sides are congruent, this is congruent to itself, sides are congruent, included angles are congruent. And then if I use CPCTC, that means that PY is the same as QY. Now let's draw in segment PQ. So what do I know? I know X is equidistant from the endpoints of that segment. XP is the same as XQ. So how far is X from the endpoints of the green segment? Same distance. Same with Y. Y is equidistant from the endpoints. Well, from the corollary we just talked about, if I have two points that are equidistant from the endpoints of a segment in a given plane, then the line connecting them is the perpendicular bisector. So by the corollary, and the number there was 6-2.11, the line XY is the perpendicular bisector of segment PQ. Well, by definition, perpendicular bisectors are perpendicular. So I've got a perpendicular line right there, and this means that the line PQ, I haven't drawn the full line, but this line goes on forever. That line is perpendicular to the given line L1. And that's what we said we were going to prove. We said there is a line that goes through P that's perpendicular to that line. If you rewind, we just started with this point and this line, and we figured out why there must be some point here and some line like so that creates a right angle. Okay, that's the end of this part.